Welcome back, guys. It's another video. My name is Mwiza Chirwa. Will take you through another topic in chemistry, which is known as air. So feel free to interact in this video. Check through some important concept on this chapter, which is another chapter for chemistry form 2. So by the end of this video and lesson, we are supposed to cover the following success criteria. Should be able to describe the composition of gases present in air, explain how the components of dry air can be separated by fractional distillation, state the uses of the gases present in dry air. So let us start by looking at the definition of air. So before we look at the definition of air, first of all, we need to look at the importance of air in the environment. So air is an essential component in the environment. It constitutes a majority part of the atmosphere. So air sustains life. This short sentence means that if there is no air, life cannot be found on the Earth's surface. Living organisms, plants as well as animals, needs air for respiration and photosynthesis. In photosynthesis, it means the process where green plants manufacture their own food. So air is also needed for the process of the food making in plants. Respiration applies the same way. That is conversion of food into energy, which is needed in the body of animals. Air consists of different gases. Here we have just been brief saying air, but air consists of different gases. As we go along, we'll be able to see the gases present in air. Now, let us look at the definition of air. What is air? Air can be defined as a homogeneous mixture of gases. I'm interested in the word homogeneous. Homogeneous means same. So it means in air, you cannot see that this one is this type of air gas, or this type is this type of gas, but it's a combination of different gases. In short, we can also define air as mixture of different gases. Gases that makes up air include nitrogen, oxygen, carbon dioxide, noble gases, as well as water vapor. The noble gases found in air include argon, helium, neon, xenon, as well as krypton. Noble gases are found in small amount, hence they are known as trace gases. So sometimes you might see that they are saying that the components of air include nitrogen, oxygen, carbon dioxide, water vapor, as well as trace gases. When they are talking about trace gases, they are referring to noble gases. Percentage of composition of dry air by volume. When we are looking at percentage composition, we are looking at the amount or the percent of each gas present in air. So in air, we are going to find 78% nitrogen, 21% oxygen, 0.93% argon, 0.03 carbon dioxide, 0.0018 neon, 0.0052 helium, and 0.00011 krypton, as well as 0.00009% xenon. So this is the composition of air. All these gases which we have looked at, they are found in air, that is constitute the air. Separation of components of air, dry air. It means when we're talking about separation, it means each component can be obtained from air. So it is possible to separate the components of air because each component has its own boiling point. Let us focus on this one. We are saying that it is possible to get each component, each gas from air because of this factor, boiling point. It means despite that all of them are mixed together, but they have different boiling point, so we can get it and obtain each gas present in air based on their boiling point. As we go along, we'll be able to look at how we can get each component. So fractional distillation method is used to obtain each gas from air. Why do we use fractional distillation amongst all methods that we use to separate mixture? Because it has a thermometer used to determine the temperatures of each gas. So it be able to collect the gas based on their boiling points. So the fractional distillation has a thermometer which can detect or determine the boiling points at which gas are you collecting at that particular moment. So the boiling points of the components of air are as follows. Nitrogen have negative 196, oxygen negative 183, argon negative 186, neon negative 246, helium negative 269, krypton negative 157, xenon negative 108, and carbon dioxide negative 78. Diagram of fluctuating column, the fractional distillation section. So it is known as a fluctuating column, like this one. So this one, we use it to separate gases or components of air based on their boiling point. So the thermometer which I was talking about is this one. So you'll be able to detect and know that this time I'll be able to collect xenon, I'll be able to collect oxygen, I'll be able to collect nitrogen. So let us look at the process of separating each component from air. So separating air into its components. So the process can occur in stages because there are a lot of things that you need to put into consideration, you need to go through first. So it occurs in stages. So the first stage is removing dust particles, or we call it purification of air. Why are we supposed to remove dust particles? We'll be able to answer those questions. But why are we talking about dust particles? Remember, we have soil, so sometimes the wind in air, we can have small dust particles within. So we are going to remove the dust particles first. So collect dry air. Collected dry air is cleaned up or purified by removing the dust particles. This is done by allowing dry air to pass through a filter paper. So within the machine that is there in the previous slide, there is the first section which comprises of filter paper which trap all the dust particles. The second stage is removing carbon dioxide. Dust-free air is allowed to pass through a solution of concentrated sodium hydroxide. A solution of concentrated sodium hydroxide to remove carbon dioxide. How does this happen? So carbon dioxide from air react with sodium hydroxide solution and form sodium carbonate and water. The carbon dioxide present in the solution, if it passes in the solution of sodium hydroxide, the carbon dioxide react with sodium hydroxide to form sodium carbonate and water, as illustrated in the equation in the bracket. Sodium hydroxide reacting with carbon dioxide to form sodium carbonate and water. The third stage is removing water vapor. So how do you remove water vapor from the air? Dust and carbon dioxide free air. The statement means you have removed the dust, you have removed carbon dioxide. So it means the air now which is remaining is free from this, is allowed to pass through a cooler chamber. That particular cooler chamber has the temperatures of negative 25 degrees Celsius. So since water freezes at 0 degrees Celsius, remember, let us check on the temperatures. Here we have negative 25 and here we have 0 degrees Celsius. So it means this one is smaller than this one. So when the water vapor, then the water vapor in the air solidifies and form an ice. It means in that particular chamber, the air which is free from dust particles And in carbon dioxide, if it passes through, since its temperature is negative 25, which is much smaller to compare with the freezing point of water, it means the water freezes and form ice. Note, it is important to remove carbon dioxide, dust particles, as well as water vapor, because they solidifies at lower temperature and can block pipes through which air passes in a fluctuating column. This is very, very important. It means all the three phase stages, they are very vital in separating of air into its components. Why? If these ones remains in air, as the air will be passing through some chambers with lower temperatures, they can always freeze out and block pipe and interfere with the whole process of separating the air into its components. So it's advisable that each and every time air is separated into its component, you need to remove dust particles, carbon dioxide, as well as water vapor to avoid blockage of the pipes. The fourth stage now is liquefying the dry air. Liquefying means making the air, turning the air into liquid air. At this stage, two major activities occurs. The stage of liquefying air into liquid, two major activities occurs. The first one, dry air is allowed to pass through a compressor. The remaining components of air is compressed in a compressor at a pressure of 200 atmospheric. Then the air is warmed up and it expands. When it is compressed, later on the air is warmed up. When the air particles or gas particles are warmed up, they are able to expand. Now the warm and expand air is allowed to pass through a heat exchanger. A heat exchanger is a chamber with temperatures negative 200 degrees Celsius. The warm and expanded air is allowed to pass through the heat exchanger for several times until the temperature falls below negative 200 degrees Celsius. So what it means is that in that particular chamber, the air will still be moving out, moving up and out. The warmed and expanded air, it means they have high temperatures. When they come here, the chamber has low temperature. It will move for several times so that it changes into liquid form by lowering its temperature. Note, the heat exchanger has a temperature of negative 200 degrees Celsius. At this temperature, the components of air with less boiling points is going to liquefy, turn into liquid air. The liquid air comprises of nitrogen, oxygen, argon, krypton, and xenon. What about neon and helium? So neon and helium is collected as gases because they have lower boiling points to compare with the boiling point of the heat exchanger. Remember, the heat exchanger, the boiling point is negative 200. So if you check on the boiling point of helium and the neon is negative 200 something, which is a little bit smaller to compare with this one. So it means they cannot turn into liquid. So they are collected as gases. The last one is fractional distillation of liquid air. The liquid air which has been collected move into fluctuating column. The liquid air is allowed to move in a fractional distillation chamber where it is heated gradually. The liquid air boils. This allows the components to evaporate one by one, depending on their boiling point. So using the thermometer, you can be able to detect that at this point, I am collecting this particular component or gas. So the component with low boiling point is collected first because it's the first one to be heated up. Uses of components of air. We have already looked at some of the components of air. So here we'll just go into details about the uses of each component. So we'll start with the nitrogen. Nitrogen is a nonmetal element which belong to group number 5 of the periodic table. It exists as a diatomic molecule. When we are talking about diatomic molecule, we are looking at the same element having 2 atoms joined together. Uses of nitrogen gas. Nitrogen gas is used to manufacture ammonia gas by Haber process, which the ammonia gas produced is used in manufacturing of fertilizers such as ammonium nitrate. Nitrogen is unreactive due to its triple covalent bonds. It is used in food preservation. It is also filled in oil tank since it's unreactive to avoid explosion, which act as a barrier between heat as well as oxygen. Liquid nitrogen is very cold, therefore it is used as a refrigerant. Liquid nitrogen is used to store semen for artificial insemination. Usually when they are getting semen, maybe for example in South Africa for bull to bring it in Malawi, they use nitrogen to store it, keep it for some time without getting damaged. Because of its inertness, it is used as in fire extinguisher to stop fire. The second component is carbon dioxide. Carbon dioxide is used in fire extinguisher. It is used in manufacture fizzy drinks as well as soft drinks. So it is used here as a preservative during manufacturing of fizzy drinks as well as soft drinks. Dry ice, which is also carbon dioxide, is used as a refrigerant. It is used to provide smoke atmosphere on stage. Usually this one is done when people are having function like musicians, they want to perform on stage, they use dry ice to spice up, which act as a smoke on the stage. Used in raising the dough during baking and during baking. Baking powder yeast decompose during baking process, releasing carbon dioxide, which causes the dough to rise. So it is used in baking. Oxygen, that is the third component. Oxygen is one of the components of air, which is more essential to living organisms to sustain their life. Remember, living things such as animals, we human beings solely depend for oxygen. Humans and other animals uses oxygen for metabolic processes. Physical properties of oxygen. Oxygen is a colorless gas, odorless gas. Odorless means it does not produce any smell. Tasteless gas. Its melting point and boiling point are negative 218.4 degrees Celsius and negative 182.96 respectively. It is slightly soluble in water, alcohol, and other some common liquids. It is a poor conductor of heat and electricity. It means it does not conduct electricity. It is denser than air. It has 2 allotropes, that is oxygen molecule and ozone. Chemical properties of oxygen gas. So the first one, oxygen reacts with nonmetal elements to produce nonmetal oxides. It reacts with nonmetal elements to produce nonmetal oxides. The oxides formed are acidic such that they dissolve in water to form an acidic solution. Look at this chemical property, it is continuing. We are saying that it reacts with nonmetal elements to form nonmetal oxide. So this nonmetal oxide, which is formed between an oxygen and a nonmetal, it's an acidic oxide, such that when it dissolves in water, it forms an acidic solution. So we can have some examples. When carbon may burn in oxygen, produce carbon dioxide. This carbon dioxide which is being produced here is an acidic oxide. If you dissolve this one in water, it produces carbonic acid. But if oxygen is limited, it means the reaction will go in complete combustion and form carbon monoxide, which is a neutral gas. Now carbon monoxide is not acidic, it's a neutral gas. Sulfur burn in oxygen and produce sulfur dioxide and sulfur trioxide. As the equation stipulates, we have sulfur plus this one, sulfur dioxide, sulfur plus oxygen producing sulfur trioxide. The same applies if this one dissolves in water, it forms acidic solution. Red phosphorus burns in oxygen. Now we are going to be puzzled here. Red phosphorus, usually phosphorus occurs into two allotropes. We have a white as well as red phosphorus. So the red phosphorus burns in oxygen and produces phosphoric oxide. Like the equation stipulated, we have phosphorus, oxygen, we have phosphorus oxide. When there is limited oxygen, it produces phosphorus. This phosphorus oxide, you can check on the subscript, which are different. This is we have 3, and here we have 5. Here we have 3. So they are different oxide depending on the amount of oxygen which was used. The reaction of nonmetal oxide with water to produce acidic solution. Now we are going to look at all the oxides which have been formed by reacting an oxygen with a nonmetal and the acid which they are going to be formed. So in the first one we looked at carbon. So we said carbon plus oxygen is going to produce carbon dioxide, which when carbon dioxide react or dissolve in water, it's going to form carbonic acid. So this is the chemical formula of carbonic acid. Sulfur dioxide plus water, sulfuric acid or sulfurous, which means sulfuric acid. Here we are saying sulfurous acid or sulfuric acid. So we have SO2 plus water, H2SO4, H2SO3, sulfurous acid, which can be upgraded into sulfuric acid. Phosphorus dioxide plus water is going to form phosphoric acid. This is the chemical formula of phosphoric acid. Oxygen may also react with metals to produce metal oxide. Remember, all what we have been doing, it was about reacting an oxygen with nonmetal elements and form a nonmetal oxide, which is acidic, and when you dissolve in water, it forms acidic solution. So another chemical property is that an oxygen can react with a metal to form a metal oxide. Now we're going to look at what would be the type of solution formed when a metal oxide is formed and dissolved in water. Note how fast the metal burns in oxygen depends on the reactivity of metal. What does this statement mean? Some of the metals are more reactive and others are less reactive. Metals, for them to be stable, is supposed to lose electrons. Hence, the one which releases electrons more easily is the one which is more reactive, unlike the one which holds the electrons more strongly. Such that group 1 and group 2 are the most reactive metals because they are reactive vigorously, because they are most reactive metals. What makes them to be most reactive? 1, they easily release their valence electrons, unlike other metals. Metals such as copper, iron react slowly with oxygen because they have strong nuclear charge, hence they hold their valence electrons strongly. Arrangement or reactivity of metals. Arrangement of metals depending on their reactivity. We have the first one is potassium, sodium, calcium, magnesium, iron, and copper. It means amongst these metals which have been arranged here, the one which will burn more easily in oxygen is this one. Because it has weak nuclear charge, it means it can release easily its valence electron. Test for oxygen gas. We can test the presence of the gas which has been produced. So if we want to test for the presence of oxygen gas, the first procedure is to take the test tube full of oxygen gas, open and lower a ground splint. If the ground splint relight, it means it's oxygen because it supports combustion. But if the ground splint does not relight, it means the gas tested is not an oxygen. This one can be illustrated by the diagram here. We have oxygen gas in a test tube which it has just been opened, and we have a ground splint here. Check and look on the ground splint. You may check on the ground splint that it has relight after it was inserted in the test tube containing oxygen gas. That is how we can test the presence of oxygen gas. So in summary, we have looked at air, the importance of air to the environment, both plants and animals. We have looked at the definition of air. We have looked at the components of air based on their percentage. We have looked at the boiling point of the components of air. We have looked at the methods that we can use to separate air, and we have looked at 5 steps that followed when we are separating the components of air. We have looked at the uses of each component of air, such as nitrogen, oxygen, carbon dioxide. We have looked at the physical property of oxygen. We have looked at the two chemical properties of oxygen. We have looked at how we can test for the presence of oxygen. Now we should look at the buzz session, a quick exercise. So in this buzz session, we have the following questions. Which two major gases are found in air? Why is it possible to separate the components of air? Name the method used to separate the components of air. Explain why carbon dioxide and water vapor should be removed first during separating air. State 2 uses of nitrogen. State 2 physical property of oxygen. Explain why helium and neon are collected in gaseous form. If you have difficulties in going through on the questions, we have one WhatsApp number here where you can ask any question if you need an assistant. These are the resources, the following resources that we use that helped us to compile our presentation. We have Excel and Success Junior Chemistry Book 2. We have Achievers in Chemistry Book 2. We have Target Junior Chemistry Book 2. For the diagram that we have used, these are the links where we can also click it and find out more about the diagrams. This marks the end of the presentation.